Okay, so E9. So we have this equation here, and we have to first, look at this and ask ourselves, does this have the required form? And no surprise, this does. So this has got a rotational symmetry, right? Does that mean you're comfortable with that? Okay. So in particular, it's y and z appear only in that special form, and so this is rotationally symmetric around the x-axis. So let's first draw that. Give myself this space. So the x-axis, and I'm just going to do a little, draw a little indication there that our surface is actually rotationally symmetric around that. Okay. All right. Now I get to pick which half plane I want to look at a cross section in. Any half plane that is hinged on this x-axis, and there's different choices that you can make. Do you have a preference between the two? Well, we kind of have 4 options. Doesn't really matter. So let's pick. Oh, I don't know. Just to make it a little different. Let's pick in there, in that half plane. Now, what do we know about this half plane? Well, that half plane is described by 2 things. For one thing, y is equal to 0, and for another thing, z is never negative. Is that cool? Okay, now what does that tell me about square root of y squared plus z squared? Well, square root of y squared plus z squared, if y is equal to 0, I just have square root of z squared. And if z is positive, square root of z squared is just z. Right? So looking in this half plane, my equation becomes this equation here. As far as I'm concerned in that half plane, it's just z equals 1 plus sine x. Right? So I need to understand how does, what does this curve look like in that green half plane. Is that cool so far? Mm-hmm. Okay. So, well, 1 plus sine x is not a hard picture to draw. It goes like this. Right, oscillates. Now, importantly, though, we're only interested in where. We're only interested in where, z. Keep in mind is now a function of x. But I'm only interested in the part where z is positive, or at least non-negative. And so I got to worry now is, do I need to worry about, are there any points where this z is going to be negative? And conveniently, no, not at all. So I'm going to actually get to draw this entire curve. And so there's kind of a, if you will, sort of axis. That's the 1 plus. And then sine x does, kind of like that. So, does that make sense? Mm-hmm. Okay. And now begins the really hard part, and that's drawing what you get when you take this curve in that half plane and rotating it around the x-axis. And the most important part of this process is to accept gross imperfection as unavoidable, right? And so, I don't know, I'm just going to kind of take a whack at it here. Let's see here. I'm not going to try to draw it on that same picture because I feel like there's too much going on there. I feel like there's a... Well, let me do it like this. I feel like there's a circular lump that kind of necks down, and then there's this other circular lump over here that kind of connects up to it. And then there's another circular lump over here. I mean, this is a really bad picture, but at least you're kind of getting the idea of what we're trying to draw. Does that make sense? It's a bad picture, but at least it conjures the right idea. Right? Is that cool? Mm-hmm. And here's the thing, just from a grading point of view, if you draw this and then say, rotate this around the x-axis, then it's clear that, if you have the right curve and if you're rotating around the right axis, then it's clear that it's just down to the sort of the artistic issue. You do have to actually draw something, but the grader will grade very liberally and generously if it's clear that you're trying to draw the right thing. Does that make sense? Okay. Yeah.
Also, quickly on that one, you would have accepted like different answers because of like the different planes that you could draw for that, right?
Well, I would. The final picture in yellow down at the bottom here would be the same.
Yeah.
Right. But yeah, you could get to it by different. So for example, you could, instead of having drawn it in that plane, you could have drawn it instead. A totally different process. You could have drawn it in this plane, and then you'd get a different, little bit of algebra resulting in a different curve. But what that curve would be, well, it would have sort of that axis, and then whoops. It'd be a different thing, but when you rotate that around the x-axis, same result. Yeah, totally. And it would be a super weird choice, but you could conceivably even. You could even use. That half plane. It'd be algebraically weird because in this half plane here, y is equal to 0 and z is non-positive, and that means that the square root of y squared plus z squared it's negative z. Right? It's fine, you can do that, it's just kind of a weird choice. Yeah.
Okay. And then the question I wanted to ask, in 1.64.
Oh, hang on a second. Are we still? Are you done with this E9? Does anybody else have questions about E9? Okay, let me stop this recording. We'll go on to that next one.